Okay guys, I'm going to broadcast the solutions to, this is homework 3.4p. Now I did mean to assign this to you this Friday, so it will again be the homework assignment for this coming Monday, since I forgot to do that. So again, this is a lot of the same. It says use the principles of atomic structure and or chemical bonding to explain the following. This is, whenever they say explain it, use what I have taught you in the class to explain it. Don't look at their language too much. I'm teaching you the correct way to solve these problems. So 4a, it says the atomic radius of Li is larger than Be. Okay, so are we talking about a horizontal or a vertical situation? We're talking about horizontal. So if we're talking about horizontal, we have to talk about atomic number. Okay, so what we're going to say is Li has 3 protons and Be has 4 protons. Thus, Be's nucleus is pulling on electrons harder, and it is thus smaller. Okay, so what we can do is we can really think about it. In Li and Be, we can look at it this way. Li has 3 protons in its nucleus, and Be has 4 protons in its nucleus, but they both are in the second energy level. What that means is they both have 2 shells. Now, because this one has 4 protons, it's pulling on those shells with a greater force, thus it's smaller. Okay? So it really is, this one just has a more powerful nucleus than this one. Let's go on and answer B. So B says the second ionization energy of K is greater than that of Ca. Okay, so this one is talking about jumps. So K forms a +1 ion, thus only wants to lose 1 electron. Ca forms a +2 ion and wants to lose 2 electrons. Thus, K will have a higher second ionization energy. Okay, that's a simple way to explain it. If you had a chart and you were looking at this, there would be a huge jump between 1 and 2 for K, and there would be a huge jump between 2 and 3 for Ca. The location of the jump is equal to the oxidation number. And let's look at C. It says the carbon-carbon bond energy in C2H4 is greater than C2H6. So let's look at C, C2H4, C2H6. Whenever they're asking about the bond energy, that is not something we can see. So we really need to look at the intramolecular structure. The Lewis structure for this is going to end up being like that, and the Lewis structure for this is going to end up being like that. Incidentally, this is called ethane, and this is called ethene. Alright, so when you look at these, there's a double bond right there, and there's a single bond right there. So, very simple explanation. Okay, double bond in C2H4 carries more energy than single bond in C2H6. All right. So you move on here to the very last problem. It says the boiling point of Cl2 is lower than the boiling point of Br 2. All right, this is not something that I've talked about, but this really relates to what we did in the last lab. So there's Cl2, there's Bl2, and without going into too much detail into this, I want you guys to think about it. You do the Lewis structure for Cl2, it looks like this. You do the Lewis structure for Br2, it looks like this. Okay, the Lewis structures are very, 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 very similar. So the only difference we really can talk about in this case is weight. And if you look at the molar mass of bromine, it's a greater value than the molar mass of chlorine. So I'm going to go over here and do this. Cl2 is heavier, and its electrons are further from the nucleus. Thus, it is harder to boil. Okay, I'm going to go over this more in class, so I want you guys to put a nice little star next to it. Just write down the explanation that I showed you, and you should be fine. So let's review. Let's go over this one more time. In the first one, it says the atomic radius of Li is larger than Be. We're talking about a horizontal relationship. Thus, we're looking at the atomic number. The atomic number of Be is 4, whereas the atomic number of Li is 3. Both of them are in the second energy level, so the 4 protons in Be are pulling in on the electrons in the first and second energy level with greater force, thus making it a smaller atom. In B, the second ionization energy of K is greater than the second ionization energy of Ca. So whenever we talk about second, not first, we're looking at jumps. So K forms a +1 ion, so the big jump is going to be between 1 and 2, and Ca forms a +2 ion, so the big jump is going to be between 2 and 3. If the big jump is between 2 and 3, then the first and second are going to be fairly low. If the big jump is between 1 and 2, then the second will be large for K. In C, it said the carbon-to-carbon bond energy. If we're talking about bond energy, we got to draw the Lewis structures, and we really got to look for double bonds. So we draw the Lewis structures out, and we see that there's a double bond in C2H4, and there's all single bonds in C2H6, making this bond harder to break. And the very last one asks you to explain why the boiling point of Cl2 is lower than the boiling point of Br2. We notice that there's no hydrogen bonding. We can't refer to bond energy. Boiling point isn't a vertical relationship on the periodic table, so the last thing we're going to do is use our logic. I want you to star this. We're going to come back to it. And just write this down. Cl2 is heavier, and its electrons are further from the nucleus, thus it's harder to boil. If you do some research on this, there's also this concept called delocalization, and we know that the electrons in Br2 are more delocalized. They're farther from the nucleus, they're moving around. This does affect its boiling point. Now, another way to look at this on the periodic table is if you find Br2, okay, Br2 is in blue, bromine, and Cl2 is in black. Things that are in blue on the periodic table are liquids, and things that are in red on the periodic table are gases. Now, if something's a liquid, it's definitely going to have a higher boiling point than something that is a gas. Guys, I'll talk to you later. Take care.